So 6.1, verifying the trigonometric identities. This is going to be fun. I mean, there's just no two ways about this chapter. It is going to be fun. Some people are going to get so frazzled, and some people are going to be smooth sailing. It's going to be great. Here are the ground rules, which I've already explained. No, you don't have to write this down. This is for those people that aren't here, but possibly out in the hall taking a test at this time. So, you can only pick one side of the equation to work on. You can't cross it by multiplying, dividing, subtracting, or adding. You have to try, if you're stuck, if you have nothing else to do, try get in terms of sine and cosine. Use identities to make substitutions, i.e. the note card. Remember, you can rewrite identities to make substitutions. What? There you go. You can rewrite them. The pen doesn't always mark. You can rewrite quotients. That's where I like to sledge things out from time to time. And then work one side till it matches the original. No working to the middle. It's there, right there. No working to the middle. That means you can't start on the left, you can't start on the right until they match. That will get you 0 points. Okay? Yeah.
So you can only work on one side.
You can only work on one side. You can use the other side for inspiration and to know the solution.
This whole chapter on those things
It-
were fun.
Almost. One section is not. The others are. It's awesome. Here we go. The first one, I call on a very, look at this. Look at the directions for 1 through 50. They don't change. Okay, don't you love that? Yeah.
Insane.
Oh, you got to love that. Because there's going to be people who are clinging to the we don't get it card. I'm going to say we, like you and the, I don't know, whatever animal you have in your pocket that you found in the winter storm. We as in a class, verify the identity.
That didn't make any sense at all.
Sure did. You'll go on the left side or the right side?
The left.
Nice. Sine of x plus. Oh, what is cotangent? Cosine over sine?
Oh, why did you do that? Well, that's what I did.
That's what you did? What did you do next?
Multiply.
Yeah. These are very relaxing. Like if we have another snow and blizzard, these would be great to do.
Yeah, definitely.
Sure. Well, I'm in charge. So I'm right. Nick, what do you do next?
I thought you put a one.
Oh, you're adding fractions. How do you add fractions? Common denominator. So you have to multiply this by sine over sine. One of the hardest things to do in pre-calc and calc is to work with expressions. Expressions are things without an equal sign. If you have an equal sign, you have all kinds of tricks and things you can do. Expressions, they're tough. Hey, sine squared plus cosine squared is what? Nice. 1 over sine of x. And there you have a perfect match. Left and right.
This is kind of good news.
It is. This is a feel-good chapter going into the winter fall. Yes.
You said that we need to do as many steps as you did.
No, I didn't say that.
Winter, fall.
I said, if you have fewer number of steps than me, that's probably okay because I show every single step. But if somebody goes from step number 1 all the way down to step number 3, then 4, then 5, it probably won't get full credit. Okay? Because I don't think there's anybody in the room that knows that sine plus cosine times cotangent is sine squared plus cosine squared over sine. I see that, I think you didn't have time to copy the whole thing, so you picked the highlights and tried to pass that off. Okay? So, there are some things that, I can see somebody going from, well, we'll talk about that later when people start, taking advantage of things like that.
All right.
So, with that said,
Why did we have to use like t and stuff? Like
T, oh, they let you know that you can use any variable you want for an angle. You don't have to be stuck with theta. You can use x's, you can use t's.
Well, yeah, I like theta.
Okay. Now, the question is,
Yeah, tangent, cotangent.
I like variety. I like the fact that some people are strong on the left and some people are strong on the right.
We do left.
We can do left, we can do right.
We'll do left. No, let's do the left.
Ooh, I say we go right in honor of the Green Bay Packers.
I say we take a vote.
Why is this voting? This is not democracy in this room.
Yes, it is.
No, it's not.
So that means, yeah.
1 over cosine. 1 over sine. Cosine over sine. I love it. With the experience we have on this, people are whining about doing the right side. They don't have any foundation for making a choice.
Wait, so even though a note card's going to grow,
Oh yeah, it's going to grow a lot.
still can't use signs.
No, but you can use it on homework and homework quizzes and homework checks and any partial tests I give. I give a lot of partial tests. Yeah. Like I'll say, okay, get out a piece of paper and do 5 identities. Go. And then I give you the problems. Well, that means,
That's just like a homework thing.
no. These aren't homework problems. These are like problems you haven't done. Like a worksheet, like when I was gone, I gave you that.
Do we only get one note card?
One per person. All right, so how do you do this one?
Multiply.
By?
Well, I mean, I meant multiply the fractions. Or should you leave it?
Okay, sure. Cosine t. Oh, sorry, cosine t. Now I have a common denominator, just like on the last one. You'll see that the more your concentration goes in and out, the harder these become. And we can concentrate for a longer period of time, the easier they become. For instance, I could ask a couple people right now that were chit-chatting, what just happened? And they say, oh. Great! 1 plus cosine squared of t all over cosine t sine t.
Multiply.
Cosine t times cosine t is cosine squared. 1 times 1 is 1. And I have the same denominator. Okay? Both denominators. All right. A bit, what? Yeah. One cosine squared, 1 plus cosine squared is not sine squared. 1 minus, huh? No, it's not. It is not.
Okay, then. Fine.
There's no mathematical way that sine squared plus cosine squared equals 1 will turn into 1 plus cosine squared equals negative sine squared.
Well, anyways.
I know, we're waiting for Sam, leader of the pack on this one.
You turn.
Sam, they're blitzing. Make a call. Let's go. Move forward. Stop. It's like that. Boom. Sure you can. Change 1 to sine squared. Why would that be a good thing to do? Well, yeah, you could add the cosine squared. You can get 2 of them out of it. Therefore, you can, then you'll be eventually getting close to getting a 2. Nice. I like these. Now wait a minute. Oh, now we get our 2. Sine squared plus 2 cosine squared over cosine t sine t. What do you think needs to be done next? What do you think, Stephanie? Well, you see how we have one denominator in our work? Well, we got a 2. That's good, we got a 2. We have one denominator, but in our answer we have how many denominators? We got 2 different denominators. We got sine over cosine and 1 over sine. So we got to split it up into 2 separate terms. So we'll split it up into 2 separate terms. Sine squared of t. Why do you do this? Well, the simple answer is I need a plus sign in between the 2 answers. The other one is I need 2 separate denominators. I don't need the same denominator. You can put it on my desk. I was just going to ask Kyle a question. You're just in time. How do you simplify this? Well, Yeah, one sine will divide off. What's sine over cosine? Tangent. Another cosine will divide off here. What's, yeah, 2 cosine times 1 over sine. Right. That gives us our cosecant. Now, it took me 1, 2, 3, 4, 5, 6 steps. The most I've ever done on a problem was 24. That's my record.
Is that in this chapter?
That was in the old book. In the old trig pre-calc book, it was half the size of this one. It had no pictures. It was all words. It was sweet. It was old school at its best.
Yeah, but you really
Yeah.
like the picture. Can you go back up?
Sure.
The first black fraction.
Yeah.
Why are there 2 cosine squared?
I rewrote 1. This whole thing right here equals 1.
Oh,
Okay, that's what equals 1. Okay? I know. Every twist and turn, somebody goes, this is like playing video games. I go, exactly. Once you get really good at it, you'll... Now, once you get good at it, oh, you know what we need to do? We need to do another one. You know what, quiet please. You know what we need to do is when we start playing the identity game. I've never actually played it. Yeah, you say, like one team says, I can do that problem in 2 steps. You know, if, you know, like Alex, he would say, I can do it in 1 step. He'd write this. Cosecant u, secant u equals cosecant u plus secant u. And he'd sit down. Well, yeah, it's pre-calc. Everybody knows the identities are going to work in this section. So that doesn't really count. So last year I had row wars, where each row would pick the weakest student out of the row to go up and do the problem. And if that person didn't get it, then all the rest of the rows got extra credit, and that row got docked 1. It was sweet. People really elevated their game that day, those 2 days. All right, speaking of elevating the game, which side do you want to work on? Excellent. What's the first thing to do? Yeah. What is tangent times cosine?
Is it really?
Nice. Yeah.
Yeah.
Tangent equals sine over cosine. What is tangent times sine? No, close. Right, sine squared. Now, if you don't see that, you want to write in the individual steps, that's fine. What is cotangent times cosine? I don't think so. Yeah, it'd be cosine squared over sine, wouldn't it? And then finally, I need another color, blue, red. What is cotangent times sine? Cosine. There. Thetas.
Yeah. They look like 4s and U's. I can't.
Can we just make theta standard?
Theta's standard. I like to be individual. I like to do my own thing. Ready? Now what do we do? What is our denominator going to be? So I'll have to multiply the first one by both of them, right? Jeez. Well, I don't know how to show my work for that, so Chase will see it later. Let's see, I'll do this. Cosine u, sine u, cosine. See, this is clear. Cosine u, sine u. What? I'm multiplying everything by 1. It's just a fancy form of 1. So I have cosine u, sine square root of u, plus sine cubed. Is it really?
Yeah.
Sine. Sweet.
Not really.
Yeah, cosine squared sine u. Oh, these are like brain breaks in on their own. Sweet. It is. I'm gonna ask somebody what to do next. What's wrong?
Now you can add a 2 plus x plus 1. Oh, you could do the cube thingy.
The cube thingy?
Yeah, the whatever, SOS. Is that what that is? No.
It might be. Look at it. You got a sine cubed right here.
And you just take it out.
Yeah, but does that get us to our answer? Cosecant plus secant?
Wouldn't that?
You split it all up into four. That has to be all that stuff has to be.
Close. There's a plus sign, not multiplying. All right. Is there any mathematical thought process that you can come up with to make this turn into this? Now, those of you that were duds earlier in your mathematical careers, by definition of a dud, I mean you see a puzzle sitting there like the horseshoes or something at Cracker Barrel, or the tee game, you know, the golf tees. A dud is somebody that tries it one time and discounts it as being not worthy of their time and pushes it away. Well, you might have a little problem with these because these don't go away. Well, look, this is number 6. We already know it goes to 50, right? This is number 6. It gets better, of the opening section of this chapter. Huh? This will be? How do you know that? Well, yeah. Well, this will be, this will have to be 1 over sine. Sam's doing a little work over here saying, look, that is 1 over sine and 1 over cosine, right? And this is kind of like cosine plus sine all over sine times cosine. Okay, so that's what that is. So if you can get to here, you can get to here, you can get to your answer. Right? How can you make the top look like cosine plus sine? Carefully. What is cosine plus sine times 1? It is. Look at this. There's a squared here. And let's see. Oh, look. If I can factor out a cosine out of both of those terms, what would I have? Isn't that, if I factor out a cosine out of the first and the third term, isn't this what I have? And if I factor a sine out of the second and the fourth, now I'll be the first to admit, some of this stuff is downright hard. But save those comments for when they really are incredibly like days long in solving. Sure. You kind of know where the line is, so you know exactly what, you know.
I don't get what the first step is. What is that?
This one?
Yeah.
I took a cosine out of the first and third terms.
Oh.
I'm taking a sine out of the first and fourth terms. Now, I will say this, coincidentally enough, I just got back my Parkland surveys from the fall semester. Can you imagine in the summer, I cover this in 30 minutes, this whole section. Bazinga! And we're through it.
Bazinga?
Yeah! I haven't seen that show in a while, so I thought I'd reference it, see if it's still on. Yeah.
That's a show?
Yeah, it is.
Oh.
Don't you know about shows like that? They're nice shows. They're like about math people. CBS. Huh? Yeah, hey, we're almost there. Is that Schluter again? It is 2. Cosine U. And if you don't make a calculus kid's day, ask them to help you with this because it'll seem really easy to them compared to what they've been doing. They'll say, oh, I can do that. Or else if they can't do it, they'll make something up like, I don't have time to do that. Yeah, that's probably what they'll say. I don't have time to do that. But it's fun. Oh, yeah. This took a whole month last year. Unfortunately, I can't spend a whole month, but I can spend some time. And there will be times in which one of you will have an answer that nobody else will have, and you'll be like, yes, that's fantastic. And it is. It's a great moment, yeah.
Are there multiple ways to do these?
Sure. If you want to live on the edge, pick the right side.
Well, even if you pick the same side.
Well, sure. People see everything different. Like, if I saw this tangent and cotangent, guess what I would have done? If I had the same problem, I would have done it differently had I not asked you for help. No, I would have done sine over cosine plus cosine over sine.
This would have been 1.
Right. It would have
We
been.
do that.
I asked, what should we do? And somebody said FOIL. I said, okay. No, we didn't. You're missing the point. Every single problem, there's a solution. Every single problem has a way of doing it. If you say, did you do it like this? And somebody says, no, you could be just as right as they are.
Okay, so
Yeah.
you would have done that. How did you got a cosine plus sine to equal cosecant plus secant?
Oh, I got a common denominator, right?
So you just times each side by.
Well, I'd multiply this by sine over cosine.
Probably equals like cosine of sine.
So I have sine squared plus cosine squared? Yeah. Huh?
Where's the cosine plus sine?
Right here. I haven't touched it yet. It's still sitting there. I would just change this to sines and cosines. See, I'm not that bright like all you. I always try to go to sines and cosines right away. See, I don't know if I could do an argument like that by myself. But I did, so I feel pretty good about the day.
Oh my gosh. Okay.
Woo! Look at that.
Brain break maybe?
Well, yeah, but, okay, now wait a minute. Now let me just say one thing. When we were right here, I kept saying this is problem number 6. A lot of you are worried and in doubt. This is probably the way you would see it worked out in student solutions. Now it makes sense why this is problem number 6. It's what, 3 or 4 steps? If you see something right away, sure. If not, well, keep working. You'll probably get there. I always like to ask.
Don't be so polite.
Don't be so polite? Okay. Look at this! This is so exciting! All right, we'll do a quick brain break.
Wait,
All right, quick one. Yeah, write down. I'll tell you who's better at these traditionally.
You.
Nope.
Freshman.
Nope. Yep. Well, if I have time in calculus, it will be. Well, we're just writing it down. We'll do a quick brain break. Okay? Now, traditionally, who does better on these problems I found are, what's the nice way of putting it? Well, it is, but I don't want people to think, oh, I fall in that group. There's no way I'll be. You know, there is a certain type of student that does really well with these. Okay? Usually the students that are quiet in class, because that means they're processing internally, and the ones that aren't. Never mind. I'm not even going to say it. I'm trying to say it politely. Okay, go ahead and stand up.
Be politically correct.
Like I could go around the room and pick out probably 5 people who do outstanding in this. All right, go ahead and point your right index finger out away from you and your left index finger out away from you. I did this earlier. Good, and put your elbows at your sides. And point the right index. There you go. Perfect, Stephanie, just like that. Nope, elbows down. Good, just like that. Now, take your right index finger and start with going up. Make a loop at your midline of your body. Touch your left index finger, come back and make a figure 8 and do that 3 times.
You're doing it backwards on the
Did it backwards.
Yeah, whatever. There we go. There you go. Good. Do that 3 times. Okay. Now, take your left index finger and repeat going up, touching, coming back through. Okay? Going up again. All right? Good. Now, close your eyes and take your left index finger up, make a figure 8, and your right index finger down and make a figure 8. Okay? You can do it. There are people doing it before.
I don't know if I'm doing it right or not.
Sure. Hannah's got it. Stephanie's close. Good. Just like that. All right, now, open your eyes and reverse. Take your right index finger down first and your left index finger up. And now try it. There you go. Lou's got it. Zeke's got it. Kyle's got it. Sort of. Good. All right, have a seat.
I got it equal to 1.
Is this your last one for the day?
You only have like 7?
All right, ready? Drawing.
Let's listen to Sam because he got it. What's our first step, Sam?
No, no, no. You have to learn how to make your own trail instead of following others.
You can't follow.
I thought they were the same person.
Wait a minute. Somebody said you're going to change tangents, sines, and cosines. That's not what you would have done first had I not said anything about the last problem.
Well, why would
That makes sense.
Common denominator? Perfect. Yes. I don't know. What the heck's going on here? What does?
There we go.
What? Who? I don't know. Elizabeth feels like chit-chatting. She's probably relaxing back in her seat, chit-chatting instead of working.
Probably.
I was waiting for you to break this stuff
No, you should be a leader, not a follower. Good.
on this problem.
Nice. Wait a minute. I got my tangent squared right here, don't I? There it is. Tangent squared. Booyah.
Wait, what?
See? Sine squared over cosine squared is tangent squared.
But then, so you can set, oh, that was a that.
Well, sure.
The 1 over cosine squared have to have the cosine squared on the bottom too.
No, it's multiplied. You can put it like this. 1 minus cosine squared
Okay.
over 1.
So, but if it was adding, you have to.
Huh? Yeah.
Wait, what?
1 minus cosine.
I was listening.
And what's 1 minus cosine squared equal? Nice.
Oh, yay.
Yay.
Oh, I got that.
Well, on your own or with help? What page is this?
466.
1 through 8, 7.
Oh, no. Go to 15.
Oh, okay. I thought you were going to say 50 at first.
No. I'm giving some people a break. I'm giving you like a day or two to get over the I can't do this, I don't know what's going on bit. I don't mean anybody in particular, but I know they're out there.
I can't.
So, and also I don't want Chase to get so far behind he gets disappointed. So, there we go. What page is this? 466?